In this video tutorial, I'm planning to do a few things regarding the meshing in the 3D Experience Release 2023x. I would like to refer to it as an assembly of mesh or mesh of an assembly because these have different meanings. So to do that, I will consider an assembly made of two parts. The two parts are shown here. And what I'm going to do is I'm going to mesh them first separately as parts. So we have a part here, we're going to mesh it. We have a part here, we're going to mesh it. And then uh, show you that I can actually go ahead and solve the problem with loads and boundary condition and things like that while these are sitting in the assembly. And then I'm going to come back and uh, pretend that these are not to be analyzed individually as parts. An assembly has to be made. And the question is, if I make an assembly, in order to put these two together, how do I use the mesh that I have already created for both of these in order to run this problem, the assembly problem? It is possible. It's not straightforward though. And once I do that, then I come back and show you actually those two meshes that you created in the part, you don't really need to use them. You can just leave it there in case you ever need it, but you can mesh the assembly itself independently. We'll see that. So my first task is uh, start with, let me get rid of this. We'll come back to that later. So I will go through these steps and then I'll come back and show you what exactly I've done. Okay. So let's go ahead and insert, right click, insert a 3D part. Okay. So this is going to be my steel part, the the big one. Let's call it like that. But I will not change the name of it. I'll just leave it the way it is. Okay. So we want to make it. I double click on the 3D shape. And on that vertical plane, I will sketch a circle of radius 100 millimeters. So this is going to be 100 millimeters. Exit and pad it by a 200 by 200 millimeter. Basically, I'm doing this piece for you. Okay. So let's go ahead here. I'm going to pad this thing under essential pad it by 200 millimeters. Okay, so that's going to be the steel piece. Why don't we put material on it while we're at it? So we go to Tools, Create a Material, and I'll call this thing Steel, and I'll call it October 20th, 2023. This is so that I can easily find it. So we just created the material. Of course, we have to input the data right here. Wait a minute. October 20th, 2023. I don't see it here. So let's check. Let me get back into it. Material browser. Let's see. Right here. Steel, October 20th, 2023. And I'm going to apply to that piece. I'm going to close that and input the properties. Check mark, green check mark. And I'm going to call this thing, by the way, yeah, okay, so it's already called steel. Yeah, fine. So structural, abacus multiphysics, mechanical, elasticity, and I put the Young's modulus of steel for it, which is 200,000 MPa, Poisson ratio 0.3. Good. Very good. You might say that, okay, should I mesh this thing now, or should I go ahead and make both of these and then mesh them at the same time? Let's go make the aluminum part and then we come back. Actually, I'm not sure how I did this thing in here, so let me see. I think I actually meshed it. So let's go ahead and mesh it right here. Later on, I'm going to put the aluminum part in there and then mesh it again. So here's how you mesh it. You put the cursor there, right click, insert, finite element model. Click on it. Just give it a second. Oh, it's right there, right here. You can see that right here. Okay, right there. Now, we go to if you double click on nodes and elements, it'll send you to the mesher, which is actually the structural model creation. So double click on nodes and elements. Notice that it will send you to the structural model creation, and you're over there. Click on the mesh, and let's do a very simple sweep mesh here. So 3D sweep 3D mesh right here, and the size of it is going to make it to be 23 millimeters, size of the elements to be 23 roughly, and then 5 layers through the length. So these numbers can be changed, but these are what I'm going to be using. And we say mesh, and there we are. So what I have done is, uh, let me actually apply properties too, because the mesh has been created, but it doesn't have material properties on it. So we click on the properties, solid mesh, and I'm going to choose the part body here. Okay, and notice that steel is selected and we're good. Okay, so we have the nodes, elements, and material properties, basically sections. So what I've done so far was exactly what you see there. In other words, I went to the part, insert, uh, finite element model. When I did that, this guy, I, I double clicked. It inserted it. I double clicked on nodes and elements. It gave me, it sent me to the structure model creation, which is the mesher. Under the meshing tab, I selected 3D sweep, and then I just put 23 and 5 layer and said mesh it, and finally I put the properties there. So this is what I have done. Now I'm going to repeat this thing for the aluminum. Okay, so exactly the same thing. Let me go ahead. I'll come back to that later. We go here. So we go all the way to the top, all the way to the top. So left double click. So I'm in the assembly design. Right click, insert 3D part. Okay, this is going to be the aluminum one, and double click on it. So if this is bothering you, you can actually hide that. Right click, hide the mesh. See that from the previous part. So on that plane, I will sketch a circle concentric with that. This is the aluminum piece, which is has radius of 50 millimeters instead of 100. 50 millimeters. Exit and pad it uh, in the opposite direction, though, not in this direction. I want to pad it this way, okay? By let me double click on this thing and put also 200 millimeters, okay? If it goes in the wrong direction, just double click on it and flip the arrow from here. Okay, good. So this is your aluminum part, but I made it in the position that it had to be, otherwise I have to put assembly constraints and put them together. I didn't do that. Okay, let's create our material on it. So we're gonna create a material, and I'll call this thing aluminum October 20th, 2023. All right, it's going to be creating the database, but with no numbers, as you'll see. Uh, Aluminum, October 20th, 2023. Right click, apply. I'm going to close that, and I want to put it on this part. Green check mark is checked. There it is. Double click on it and put the proper values in there. So structural, abacus multiphysics, mechanical, elasticity, elastic, and aluminum 70,000 MPa, and Poisson ratio 0.3. And then we say OK. Good. All right, we can mesh it. So remember how it worked. So we put the cursor right there. Right click, insert finite element model. Okay, there we are. It's inserted. Okay, now we're going to go mesh it. How do we mesh it? We double click on nodes and elements. Right now we are in assembly design, but when I double click on this guy, it's going to send me to the structural model creation. So double click, structural model creation, and I do exactly the same thing under the mesher, sweep, 3D sweep, and I select this part, and notice that it sweeps in that direction. Again, 23 millimeters and 5 layers. Actually, I think I used a different size because I want you to be able to see it. So I put down, well, I guess not. I still use 23 millimeters. Fine, fine. So what you see here is exactly what I did. In other words, first inserted the finite element model. Okay. Once it did, then I double clicked on nodes and element. It sent me into the mesher, and then use the 3D sweep mesh to create these things. And I'm going to do exactly the same thing. So, all right. So we say mesh. There we are. Okay. And we close that. We also apply properties on it. So properties on this solid section, and it's this part, part body, which is aluminum right there. We say okay. All right, so let's do a quick save here. So where are we? If you go all the way to the top, okay, I have an assembly made of two parts. The steel part with its own mesh, and the aluminum part with its own mesh. First of all, I can see them simultaneously. That's because this is hidden. Right click, hide and show. They're there, okay? And if you want to see just the mesh, so you want to see the mesh on this, put the cursor there, right click and hide and show. There we are. Good. Uh, yeah. So what we want to do now is to go and, well, first of all, before I create the mesh on the entire assembly, you might say, well, why do I do this? Why do I not go ahead and mesh the whole assembly at the same time? Well, let's say that we decided to look at the steel part, apply some load and some boundary conditions, and then wanted to see how it looked like. No problem. So you go to the steel part right there. This is the steel part. Double click on it. Okay, double click on it. This steel part has a mesh and properties. So I go to the top left corner and I go to structural scenario creation. You click on it. Immediately it just basically takes you to the part, that the steel part right there. So this thing that you're going to do only has a steel part in it because you went there, you went to that part and said, let's go to the mechanical scenario creation. So it says, what is structural is what you're doing. What is the finite element model? It's the one that we created for steel. Remember, we have one for steel, which is right here. The aluminum is not even in the tree because this is only for the steel. So we select it and we say, okay. Just give it a minute. Good. So we go to procedure. This is only the steel part. Procedure, uh, static step. Let me take away the nonlinearity out of this so that it just runs in one step. Let's apply some boundary conditions. For example, let's hypothetically say that we clamp the right side. Where is that clamp? For example, this side. All right. And then we apply maybe a downward load here. So downward force or something like that. Load, let's say a force on that face in the direction Z minus, these are all dummy numbers, minus 100 newtons, okay? 1,000 newtons, okay, good. All right, now we can go and run it. We can do a model check, scenario check, and run it. I know that there won't be a problem, so I'm just going to run it. Ordinarily, I would suggest that you do a model check and a scenario check and simulate, but I'll take my chances. I'm just going to run it. It's a very simple problem. It's just the aluminum, just the steel piece by itself and nothing else. We'll wait for the dialog box, which says simulate, to pop up. It's not running yet. It's just waiting for that box to pop up there. And we say, okay, it's going to run in one shot because I took away all the nonlinearity effects. I just do it in one shot, and we can look at this steel piece deflecting under the clamped right side and the boundary condition that we put on it, or the force that we put on it. And we can keep it there. We can save it. It's almost done. Yep, done. Okay, I close that, and there we are. You can do animations and all. This is just the steel. You can plot the von Mises stress and displacement and all these things. Okay, good. So this is created and saved there. You might say, well, actually, I'm gonna, I can save it. I didn't, but I don't have to, but I can. I go back here. I say, oh, wait a minute. You know what? I actually want to analyze the aluminum part too. No problem. So you go to the aluminum part, which is right here. Let me uh, contract that. Go to the aluminum part. We are right there. Right click. Sorry, you go to aluminum part. You go to 3D structural scenario creation. Okay. And what model do you want to pick? We want to pick. Uh, oh, cancel that. Cancel. No, no, no. Let me see. So what we do is we go there, right, we go to the right assembly design, right there. We are there, okay, and then we go to structural scenario creation, okay, and the model that we want is actually the aluminum. The aluminum was this had this mesh with it. Say okay, and what you see here is only the aluminum part, okay, and let's say that we want to uh, maybe first of all, let's make it a static step. Not take away the nonlinearities because I want this thing to do very quickly. And then, for example, let's say that we uh, put a clamp that side. So boundary condition, clamp that side. Okay, and maybe we want to put a pressure on this side. Okay, so we go to pressure, load, pressure on this face. Let's say 1,000 MPa, 100 MPa, something like that. You say, okay, good. And once again, I know that this is going to run. There won't be any errors, so I'm going to go to simulate. Instead of model check and scenario check, which I highly advise you to do, I'm just going to simulate. This is only the aluminum part. The steel part, we already did an analysis on it and it's sitting up there. I didn't save it, but you can save it and close it if you want. But anyway, here I'm going to do that too. Obviously, this is going to get compressed. The other one bent because I put a downward load on it. We run it. So you can see why I may decide to put a part in an assembly and mesh them individually. Okay, mesh them individually because maybe one day I want to analyze those parts. This is all done. Extracting the results. Close this, and this is the aluminum part, which is being compressed. So it's sitting up there. I can save this thing and then close it, or I can keep it up there. It really doesn't matter. Okay, so let's go back to the original problem. Suppose here we decide that, wait a minute, what I want to do, I want to do this thing as an assembly where, for example, this end, well, let me do it like that. This end is clamped, and maybe at that end, I want to put a downward force. And these are perfectly welded together. So the question is, okay, I can do that. There's no problem. I go all the way to the top, first of all the way to the top, all the way to the top. Now, I have to, the question becomes, should I be using these meshes? Well, that's entirely up to you. If you want to use these meshes that are already created, and because meshing can be an expensive proposition, but anyway, if you want to use these meshes that are already created, it's possible. However, there's a few hoops that you have to go through. So let me go here. We already saw that. Okay, so we already did this. That's what I'm going to do. Just a second. Yeah, that's going to be new. So the question is, if I want to do this thing in an assembly and I want to use those meshes, what do I do? We'll come to that in a minute. So first of all, you go all the way to the top. See that? I'm all the way at the top, at the assembly level. And then insert a representation. And a dialog box will show up. It says, okay, this representation, what do you want it to be? Well, I want a finite element model. Okay, so let's go here. You don't, remember, we decided that we want to use those meshes that are already created. You don't have to, but that's what we decided. So right click, insert representation, right there. Notice that you don't see a finite element model here, okay? Representation. You click on it, this guy pops up, and it's this finite element model that we want to select. And when you look at it, it puts this branch, although we have it down here underneath the parts, but it puts a branch called node finite element model. What is that? Finite element model is the number is also different from these. If you check the finite element model here, for example, for this, that's not the same as that, and this is not the same as that. So let me contract these. Okay, good. The question is, well, okay, I did it, but what happened? Well, unfortunately, you have to go through some hoops. And here's what you do. First, I'll show you the slide. You're right here. It did it, but the question is, what happened? There's nothing there, and you're absolutely right. So this is what I need to do. Okay, and what do I mean by that? First of all, double click on uh, on uh, 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 finite element model. Okay, double click on. Let's see now. Well, we're going to find out whether nodes and elements or finite element model. I'm not sure. Let's find out. Let's go there. Okay. So double click on this. Notice that right now I'm in assembly design. Double click on that. Yep. All right. So this thing pops up. What do I have here? This thing pops up. I double click on finite element model. This thing popped up and it says, okay, you have two parts in your assembly. Which one or which ones you want to participate? Well, I want both of them to participate. So either I select this or I select it individually down here. Okay. So what I'm showing you right now is this. Okay. In the event that you close this before doing that, okay, let me do that for you. Let me cancel that. Let me cancel that. We have to do this, right? But let's say that we forgot or we forgot to check this thing or cancel that. Okay, so what I can do, I can go to the setup and double click on contributing shape. What is that? Uh, shape manager. You see, comes up again. So that's what this thing is saying. In case you did not check these and you lost your chance, you can always go back and by selecting on this, select it. Okay, good. All right, I did it. So we did this, but then the question is, now what? Nothing happened. You can see that. Note that nothing changed right here. Nothing changed right there. So here's what you do. You go to contributing finite element, you click on it, and this thing pops up. So what I'm showing you now is this. Okay, so I clicked on here, contributing finite element model. So I instead of in setup, instead of the first one, which I already used, I go to contributing finite element model and this icon and this guy pops up. So here's what you have to do. This is for these are the finite element measures that we created essentially. Okay, right there. So you put the cursor on the first one here on this row. See that? Right click, select FEM, and this is for the steel part. Ah, okay. And then put the cursor there. Right click, select FEM, the other one, and then we say okay. So this window, this dialog box is exactly what you see here. I've done it twice, and this is what you get. Okay. And then we say okay. Still nothing shows up here. Okay. We did it. You went through all the steps, but uh, sorry, but you you might say, well, how do I know that actually they're there? Well, they're there because they're there because if you clicked on this, hang in there, it shows you. See if you can see those elements icons here, but if you double click on node and elements here, it pops up. It shows you that the swap meshes are there. Believe me, it's there. Although it doesn't reflect it, doesn't get reflected here, just like it did, for example, for these parts. You see that in the parts, they got reflected here, but this does not. All right, so now now we're going to go. Now we're going to go to the structural scenario creation. This is an assembly now. It says, what is the model? The model is that last one, the big one that we created, this number, 17105, 17105. And then structural, we say, okay. All right, all right. So what are we planning to do? First of all, if you don't want to see the elements, right click, mesh visualization, and don't show me the element, or you can do it from the tree, either way. Okay. So suppose that we want to clamp that end, no problem. First of all, you have to go and create a static step. So procedure, static step, check the nonlinearity, take the nonlinearity off. However, uh, because it's going to be a tight contact, uh, it may it may come into the picture. You turned it off, but it may come into the picture. Okay, good. So we go to the boundary condition, clamp, for example, that face. We say okay, and put a downward force over here. A load, downward force right there in the direction Z of minus 1,000 Newton. Okay, good. It looks like we should be okay. We're going to run it. However, you'll see that it will bomb out. So let me first run it, show you that it will bomb out, and then we find out why. So I'm not going to check these two. I'm just going to literally run it. It will bomb out because these two pieces of an assembly, they're not talking to each other. They don't know that they're attached to each other. When you do a problem with assembly, you must create interaction between them. They can be contact, they can be tied, and they can be other things, for example. We did not do that. After it bombs out, I will come and do that for you, okay? Basically, it tries to converge. You won't be able to do that, and then it says analysis failed. Iteration, we'll see. You see, it tries to converge. It won't be able to do that. And it says analysis failed due to error. So we say fine. And you won't be able to see anything because it actually never converged. So close, good. So what do? We go to interaction, and there are different ways of doing it. One of them is contact detection. Find out which two surfaces are in contact with each other. So make sure you select it. Well, first of all, you say, first of all, when you find them, tie them together. This check mark right there. See that? This check mark? Okay. And then you click on the find the surfaces, and then apply or okay, and notice that they did find it. The magenta is showing here, the green is right underneath it, you can't see it. You say okay, and they are tied together now. So if you look at the case under static step one, there is right here surfaces surface-based contact. Of course, they're tied. You can see that it tied it together. We say okay, now we're going to run it, and it's going to be fine. So let me see why this is doing. Let me see now. Yeah, okay, so we haven't got there yet. We will. So we are using the good old meshes that we created for this assembly. And I told you why you may do that. Say, okay, why you may do that? Because meshing is an expensive proposition. A good mesh can be expensive. You already meshed something that you like. Now, if you wanted to go and create another mesh, and we will, after this thing, I'll show you, what if you want to ignore those meshes? What if you want to do it again, okay, at the assembly level? It can be done, but you have to pay the price. So let's see now. Let me see if it's doing it iteratively. Yeah, because contact business came into the picture, okay, so it'll try to maybe actually, yeah, actually it also does it in two step because I unchecked the nonlinearity. So here, let me close this. This is the initial one. Here's the second one right there. Okay. Now, this result, you can save it and you can close this, or you can just leave it there. It's not hurting you. So let me go. Let me just leave it there. I go back to my parts assembly. I go back to my assembly, and I'm gonna delete this for you. I'm gonna delete this. Okay, I'm gonna delete this. Okay. I'm going to delete this because these things are already there, because I want to show you from the beginning how it works, okay? These elements are going to be there. I'm not going to delete the element. I'm just going to delete the one that I created at the assembly level. So right click, let me go all the way to the top, right click, delete. So where are we? We are back to this situation. And what do I mean by back to that situation? We are back to, okay, we have seen this right there. We're back to that situation, okay? So we follow exactly the same routine. In other words, we go down here, just like before, exactly what we did before. We go put the cursor there, right click, insert, representation, finite element model, and it did it right here, okay? And what I want to do is I double click on nodes and elements. I double click on this, double click. Actually, let me do the following. Let me double click on that, okay? Because remember, what we have to do is say which parts are going to be participating. So let me cancel that. I double click on finite element model right here to tell the software which ones are we trying to do. We missed that window. We missed that opportunity to select those things. But remember, it's down here too, contributing shapes manager, because I closed that. All right. So, but we do exactly the same. We can do it again from here, right there. We say okay. Remember, I said here that we go back. In case you did not get this or you inadvertently close it, go to double click on that, go to setup and contributing shape manager. You have already seen this, okay? That's why, where is it? Where are we? We are here, okay? So let's go ahead and wrap it up. So double click on nodes and element to put you into mesh. You are in the mesh module. See, structural model creation. When I double clicked on finite element, it actually put me there. You go to mesh. Uh, these things are not the mesh that we created. These are the good old meshes from here. Let me hide it. These are the mesh for the part, for the two parts. This is not what we just created. We have to create the mesh. Hide and show there. I do not have a mesh for my assembly. What you were seeing were mesh for the part that you can either delete it or leave it like that, because who knows, maybe one day you need it. So here's what we do. We're going to do another, well, actually, let me try this time. Instead of doing a sweep mesh, I'll do a tet mesh just to show you that it can be different. So this one, mesh it. There we are. Okay. Actually, let me make it a little bit smaller. Double click. Let me make this thing a little bit smaller, maybe a 10. There. This was created. Do it again for this guy, for that guy. I'm not going to make this thing 10. I'll make it 30. How about that? Mesh. There. You want to hide it? No problem. So right click, mesh visualization. Don't show me the mesh. Or don't show me the mesh. Don't show me the part. Yeah, right there. Uh, tetrahedral. One of these is not what I wanted. This one may be from before. Let me check for a second, because I did not do a tet mesh. Oh yeah, this one was not hidden. Oh, wait a minute. Uh, hang in there. This is the one from before. Oh, it's right here. Right here. So show me the mesh. Okay, so let's I don't like that. So let's go all the way to the top. Oh, here. Hidden. See that? Hidden. Because I could swear that these are tetrahedral. What we were seeing was not actually tetrahedral, was swept. So I can hide this, and I can hide that. Hallelujah. These are the ones that are created. These that you were looking at were from before. Okay. Now let's apply our loads, for example. I don't want to see the mesh here. Okay, let me just show me the part. Okay, good. So now we're going to go, while we are in this, we are in the structural model creation and we are at that level, we're going to go to structural scenario creation, and it's going to ask you, do you have a mesh? Yes, I do. Remember before I had to go here and kind of uh, beg for it. Remember this stuff? Because I had to go and get it. Not anymore. Not anymore. So I already created it right here. See, finite element model 40130. Oops, sorry. Wait a minute. Sorry, 17106 right there. 17106, and we say okay. Good. So let's make a step procedure, static step. Take away the nonlinearity. Okay. Boundary conditions. Boundary conditions. How about, for example, clamping that side, just like before, and applying a, oh, I don't know, let's apply a pressure here, a load, a pressure on that face. Uh, Actually, I put a downward load, right? So cancel that. Let's apply a load, a force on that face. I'll do it in the different direction. How about that? In the direction Y. So, for example, 1000 Newton. You say okay, it shows you like that. And don't forget to do if you run this thing, it's going to bomb out because remember, these two things don't talk to each other. So we go to interaction, contact detection, tie them together, find them and tie them together. Find them, tie them together, apply. It did right there. And now we can go and run. Simulate. I'm not going to bother checking. Model check and simulation check. I'm going to run it because I know it's going to work. Sometimes I have to eat my words when I say that. Just give me 1 minute. And I'm going to show you also my last slide from uh, the PowerPoint. Okay, good. It's going to run. And it's going to be quick. So you can see why I call this thing, oh, oh, you know what? You know what? I forgot to do sections. Right here, properties are missing. Right there. You see that? Right there. So let's go back to the uh, let's go back to the model. Put properties on it. I forgot to do that. So we go to properties, solid section. So on this part body, I want to take part body. If you're having a hard time, you can do it from the tree. So part body. So that's going to be the steel. And then another one on the other guy. I told you I have to eat my words. Every time I said that, something didn't work. Okay, so now we have properties here. You can see this. And now we're going to run it. So back to the analysis. And you can go back to the analysis either by clicking on standard, going to scenarios, or just double click on. And now we're going to run it. Once again, I'll take my chances. This is already 45 minutes, but I think it's something worth knowing. You probably already know some of this stuff, or all of it. I'm not sure. Remember, this mesh that you're saying is not the same mesh that we created for the parts. Those are still there. If you ever want to use those are still there. I didn't delete them. Okay, it didn't bomb out. I don't think it did. Oh, it's running. Extracting results. But that's why I call this tutorial assembly of meshes or mesh of an assembly. Okay, done. So close that, and there we are. This is the run that we just made. Remember, we pushed it this way. Now, so here is now all of these analysis are going to be there. You can save them if you want. You know, the only problem is that the third one that we did, because I deleted, I think I deleted the finite element model at the assembly level for it is going to be problematic. But the ones for the parts, and this one, of course, is going to be there. So here's what I wanted to say. That this is what we did. That's what I forgot to do. Now I came back and fixed it, and these are still here. They have nothing to do with what we did up here. Now the tutorial is finished. However, what I will do, I will go through these. It just takes a couple of minutes, maybe a minute or so, through all these slides in case you want to remember how these things work. You have a record of it. Yeah, this was the last slide, and good luck.